Hi everybody, welcome to Advanced Maths 101. Today is day 5, 15th May 2024. Here we have two questions with us. It says that consider a quadratic function f of x, which is given, this is a general form of quadratic equation, and it is given that a, b, c all belong to real number and a is not 0. Because if a is 0, then it will be not quadratic, right? So, uh, satisfying the following condition, we have three conditions. We need to find basically a in the very first question, and first we need to find the f dash one. So for that also we will be needing the value of b also. So let's see. First of all, the question says that we have f of x minus 4, f of 2x minus for all x belonging to real number, and it is also given that f of x is always greater than equal to x for all x belonging to R. What it means that say f of 0, so it will be greater than equal to 0. F of 2, it will be greater than equal to 2, right? Like so, one thing you can see that it will be let's see, here we have the minimum value of fx is 0. So if this is parabola opening up, so then only its minimum value will occur. If it is like this, opening downward, so its maximum value will be 0, right? So this cannot be the case. This will be the only case. So we can also say that a will be greater than 0. The leading coefficient of the quadratic polynomial will be greater than 0. Okay. Now we have this thing, and you will see that in quadratic uh, there is symmetry, right? If you take a general expression of y is equal to x square, here we have symmetry about y-axis. About y-axis we have symmetry. Like if we go to on the right hand side, we will get this. If we go to same distance, we will get this, right? So there is a symmetry about y-axis. So here also it is a opening upward parabola. So here also it will have symmetry, but we need to figure out about which point it will have symmetry. Okay, and since it has the minimum value of 0, it also means that this cannot be possible, right? This cannot be the case because for then the minimum value will not be 0. It will be a negative number, right? So for minimum value to be 0, it must only touch the x-axis. Okay. So now, if you see, let's put x equal to what? Let's say put x equal to x plus 3. So what we will get? F of x minus 1 equal to f of minus x minus 1. And if you see it carefully, what we will get? It will be f of minus 1 plus x is equal to f of minus 1 minus x. As you can see from over here, that on moving to the right hand side, like say we have the number minus 1 over here, so on moving x from minus 1 on the right hand side, we will get certain number corresponding to it, and if we move the same x from minus 1, we will get another number which will be the same. So you can see that it will be symmetric about minus 1 point. Okay. So, and since it has only one zero, so we can say that f of x will be what? As it is a quadratic, so it will have a repeated root. So it will be simply this, right? Here you can see that minus 1 is the 0 of the polynomial. Okay. So now let's move on. So what we figure out that f of x is equal to a times x plus 1 square. Okay. Now we will use this condition. It says that f of x is greater than equal to x for all x belonging to R. Okay, and here we have f of x is lesser than equal to this thing for all x belonging to 0 to 2, where 0 and 2 is not included. For our sake of simplicity, Let's choose the number 1 as it lies in this region also, and it lies in this region also. So let's say we have f of 1 from this. Say this is condition number 1, condition number 2. So from condition number 1 we can say that it will be greater than 1 from condition number 1, and from condition number 2 we can say that it will be lesser than equal to how much? It will be 1 plus 1, 2 by 2, 2 square. So it's 1. So you can see that a function f of 1 is greater than equal to 1, and it is also lesser than equal to 1. So from here what we can conclude that f of 1 will be how much? It will be 1. Okay. And now putting the value of this thing over here, what we get? F of 1 equal to 1 equal to a plus 1 q square. Okay. So what we get, the value of a is equal to 1 by 4. So now we have the questions. Now we have our function f of x equal to how much? It's 1 by 4 x plus 1 square. Okay. So leading coefficient of the quadratic polynomial is how much? 1 by 4. Okay. And f dash 1 has a value equal to how much? So f dash 1. So first, let's say f dash x equal to how much? It will be 1. And then differentiating, what we get? X plus 1. And then x differentiation is 1 only. So now putting the value of x equal to 1, but we get 1 by 4, 2 into 1 plus 1, 2. So from over here we get the value of f dash 1 to be 1. So that's it from this question. The key part over here was to check the symmetry, like about which point the graph of the quadratic will be symmetric. So we can get an idea about the root of it because there is only a single root. Okay, I hope it is clear. See you tomorrow.